Okay, so here we're going to sketch the graph of circles in polar curves, and there are these two fundamental or beginning ones that we'll see in books, in textbooks at least. They will show circles, and we'll give us circles. So first of all, I'm going to start off with r equals 2. This is the set of all points in polar coordinates of the form 2 theta, because remember r comes first and r is 2. So what will that look like? Well, it actually ends up being really simple, but it's something that we really want to talk about. That is going to be a circle, as I said it would be. Okay, so the points that I'm drawing are a distance 2 from the origin. A circle is a set of all points that are distance of radius r from the center, and the center here is the origin. And so now, I can maybe draw this easily because this has a drawing tool for making circles. So now I can adjust it, and then we get it. There you go. So this is r equals 2. Okay, now on to more stuff. Let's look at another form that will give us a circle, and this is an example of that. And this is r equals 2 cosine theta. Now, one way to look at this is that you could think of this as a one-leaf rose. The coefficient of theta is 1. It's going to have one leaf. So, but actually, it turns out to be a circle. The one leaf, the petal or whatever it's called, ends up being a shape of a circle. So we're going to multiply by r, and I, fully appreciate that this does not seem like a natural thing to do. So there's some memorization involved. Multiply by r, and then we're going to use that x squared plus y squared equals r squared, and that x equals r cosine theta. Those are identities that we have with polar coordinates. And that's then taking this polar graph, this polar equation, and putting that into a Cartesian equation with x and y. And this is the equation of a circle. We have to sort of move things around to see that. All right, what we're going to do here is we're going to complete the square. So I have negative 2x, and I take that coefficient and divide by 2 and square it, and I get plus 1. So this gives x minus 1 squared plus y squared equals 0. And this is a circle. Oops, no, not 0. Makes no sense at all. Of course not. It's radius 1, so I didn't add. Anyway, for whatever reason, just plain mistake, I did not add 1 to both sides. So I add 1 to the left side, I have to add it to the right side. So this is a circle of radius 1 and center with not polar coordinates, but with rectangular coordinates, are also called Cartesian coordinates. One, 0. All right, so I'm supposed to we don't want to get those two mixed up. All right, let me see if I can just fit this all on one page here. Okay, so 1, 0 is easy enough. That's the center. That's actually not the part of the graph, but I colored that in. And then it's going to have radius 1. So let's take out a good color. Green is a good one, I think. Okay, and I'm going to draw a circle here. Sort of feel like I have more space than I need. Anyway. Yeah, seems almost, there he goes. It's just perfect there. So there we go. Okay, is it about the right X and Y? I don't think I'm going to do that. Okay, so this is R equals 2 cosine theta. And that's a circle, and the other one above is a circle. What do we see? They're not to the same scale. But what also I can see is that, actually, sorry, they are to the same scale. Sorry about that. What I can see is that they have two different types of equations. The equations look quite a bit different, really. And so what's going on with that? Okay, so we see that we get two different types of circles. The first one is centered at the origin. The other one is centered at, as you see, at Cartesian coordinate 1, 0. So they're a little bit different. Okay, so I think that's all.